whatever arithmetic logics processing has been done, it will store finally into the accumulator. Then if carry is generated, then these flags are going to work, and if one carry is generated, then output will be 1, otherwise 0. So after this whole process is done, it will be stored inside the instruction decoder that I've also explained it just before this topic. So what are these register arrays and memory pointer register? These are also the components of the obviously the 8085 microprocessor. So what are their main works? Is as soon as the 16-bit address is coming from the peripheral device inside the microprocessor, so they will contain the address only, and then only it will uh, take sorry yes. What are these memory pointers and register? This memory pointer will store the current address of the data which is being processed. So as the data will be sent in sequential order, that is one by one from the 16-bit address is coming from the peripheral device inside the microprocessor, then it will stay inside the register arrays, then one by one till whole space of this register array has been occupied into it, then it will come to the memory pointer one by one. The values from the inside the memory pointer will go inside the accumulator, and the whole processing has been done, and then finally we get the machine language. So like here it is mentioned 8-bit data, it was bidirectional. Why was it called? So I have already explained it, that it will take the data from the peripheral device inside the microprocessor, and as the proceedings or the processing of the data or the command which is given by the control unit has been completed by the microprocessor, so it will go from the microprocessor to the screen itself. So that's also. So coming to the next, that this is the inside of the accumulator, and this is flag register and stack pointer, data bus. This whole lot which you have already studied is explained in brief. So we'll have a look at it one by one. So like in this figure, the accumulator is storing the output which has been obtained from the ALU, yes, and then ALU, these all things I have explained you, so no need of going through it again and again. So instruction decoder work was also explained by me, converting assembly language to machine language. And then what is the work of the stack pointer? Like as you are typing, for example, just listen very carefully, that for example you are typing any LED program. So when you are starting the program of the LED or any other work that you want to do, like any other machine related work we want to do, or switching on the light, switching off the light. So as soon as you start writing the code, the starting portion will be taken by the stack pointer. That is the first location on which the address of the first set of lines of code which is written is stored inside the stack pointer. So stack pointer contains the record of the first address of the set of codes. Like in the C program, if you are writing hashtag include stdio.h, it is a type of program starting point, so it will take that address inside its memory. Stack pointer will having that address, so it will. And what is the use of this stack pointer? The use is nothing but when you want any other program like LED, if you want to type on in or if you want to attach this LED program in with another machine, another working of machines program, like like we can say switching on the light along with the sound. Like as soon as the light will be on, the sound will also be on. Okay. So like LED program I've written somewhere else. So I want to, if I don't want to write it again in the sound program where we'll get the sound of it, so we can directly copy on it with the help of the stack pointer only. So I think now I've made myself more clear about the stack pointer. So coming on to the counter. So program counter is nothing but it stores the address of the next data which is coming from the input. Okay. So register array will store the information. Already I've told this. So classification of memory, we can have this set of code after some time, or we can just have a look at it also side by side. Like classification of the memory, how is the memory classified? It is classified into two: primary memory and secondary memory. So primary memory is mainly random access memory, where you can directly access the data or the information from it, and the values which are stored inside the RAM will not be stored for too long. Like for example, when you are working on the computer system, writing, typing something on Word or anywhere like Microsoft PowerPoint and all, and you have written, as soon as the light is gone, these data will be vanished. You will not get the record of that data if you have stored inside the this particular RAM. And read only memory is very advantageous in it, that it will contain the data as soon as the light is gone, so it will retain its data. So storing data, like it is of the type ROM, EPROM and EPROM. Like programmable, this EPROM full form is programmable read-only memory, and electrically programmable read and erasable programmable read-only memory, and electrically erasable programmable read-only memory. So